Hey everyone, the start of Unit 2 is happening. We're going to be investigating statistics over the next little while, and to get started on that, Module 5, we're going to be looking at the different ways data is represented and how to visualize data effectively. So this is the first of a 4-part video series on representing data in histograms and the start of our statistics unit. So before we go too far, what is statistics? The people are familiar with the term, but you might not actually know what exactly statistics is about. So statistics is about analyzing data to interpret it and to possibly make decisions with it. There are actually 2 different branches of statistics. For the first bit, for Unit 2 in this course, we're going to be focused on what we call descriptive statistics, which are about describing what is actually known, about finding averages, how spread out data is, and those sorts of things. And then after that, we're going to move on to the second branch, which is inferential statistics, which is about using data that's been collected to make predictions. Okay? There's different reasons why we might want to make predictions or why we have to make predictions when we don't have the data required. Sometimes it's because we're only able to collect data on a sample and not on a population. And sometimes we're collecting data in the present and hoping to make predictions about the future. Okay, so the next step of learning about statistics, again, is getting used to some of this terminology. I've used a few terms there that you might think you know what they mean, but you might not know exactly what they mean in a statistics setting. And an example of that is the terms population and sample. So the first thing we want to do is make sure we're well aware of what those terms mean. So a population in the statistics sense is the entire group or set of similar things being studied. It could be a human population, or it could refer to just items of a particular type being produced at a factory, or again, any similar items that we would expect to have the same characteristics around them. And a sample is any subgroup from a population. When we collect data on a population, we're actually calculating parameter values because we have all of the information. The data that we're analyzing and producing are called parameter values. They're true. They're not going to change over time because we have all the possible data that we could ever want. Okay? But when we collect data about a sample, those values that we're calculating are statistics, okay? They're representative of the sample, and where statistics have power is that we assume that statistics estimate parameter values. So we assume that knowing about a sample helps us know something about a population. So a bit more terminology here. So whatever it is that we're interested in studying is called our variable. Right? So this could be eye color, this could be weight, this could be height, all sorts of things that we might be interested in studying. Those are our different variables, and variables come in different kinds. So we can have qualitative variables. Qualitative variables are descriptive. And there's different types, right? There's all sorts of types of different descriptive variables we might be interested in collecting information about. We might be interested in things like eye color. What else? We could be interested in emotional state. Emotional state. We could be interested in the type of medical treatment somebody receives, right? All different things, and such a small subset of things that we might collect information on. Okay, now what's interesting about qualitative variables is that there are different types of qualitative variables. There are qualitative variables that have a natural order to them, right? So if we're thinking about describing your emotional state as good, average, poor, right? That would be an example of variables that are ordinal. There's a natural ranking in how those variables appear, whereas nominal variables are qualitative but don't have a natural order, so maybe like red, blue, yellow. Of course, we could alphabeticalize nominal categories or those sorts of things, but they don't actually, they're not ordered. They don't have, they couldn't be put on a line from better to worse or higher to lower. Okay. Okay. We're going to look a little bit at qualitative variables when we're making graphs. Some types of graphs use qualitative variables, but most of our time in analysis is going to be spent looking at quantitative data. Quantitative variables and data, right, involve numbers. And just like when we were talking about accuracy and precision in first semester, we talked about how numbers have different types, right? We can have exact numbers or approximate numbers. That's similar to when we have quantitative data. We talk about discrete data, which is counted, right? Those are like our exact values. So if we ask the question, how many patients are seen at an emergency room at a given day, how many medical treatments has somebody undergone, right? 0, 1, 2, 3, right? Things that are counted are discrete. Okay, and then the other type of quantitative value we can have is continuous, and continuous are measured or approximate values, right, coming from things like weight, height, and we're going to spend a lot of our analysis time over this unit looking at continuous quantitative data, right? Again, we know that when we're dealing with continuous quantitative values, it's really important to know what units were used and to know how precise and how that data was collected. So before we move on to the next little bit of terminology that we need to know around sampling techniques and how data is collected, there's a few practice questions here for you to try and get used to that terminology that we've introduced. So pause the video, try and fill in these blanks or categorize, and then press play once you've given it your first shot and check your answers. Okay. So a population consists of all subjects being studied. A sample is a group of subjects selected from within a population. Given the scenario of a quality control setting where 15 vials of a product from a batch were tested, the sample would be the 15 vials from the batch that were looked at, and the population would be in the entire batch of vials. As far as whether the following variables are qualitative or quantitative, BMI is a tricky one to start with because it can actually be either. It can be qualitative when we use the terms like underweight, normal, overweight, and obese to categorize people's BMI. When we actually measure BMI, where we take a weight and divide by the height squared, we're getting a number, and so in that case, it's quantitative. Gender is qualitative. Time from birth to death is quantitative. Vital status, whether somebody's alive or dead, is qualitative. The measure of waste in urine is quantitative. We'd be looking at the grams per milliliter, the actual density of waste there. Genotype, the genetic makeup of an individual, is qualitative. Body temperature, measured, quantitative. Number of hospitalizations somebody receives, again, is quantitative. And if you think about those different measures, again, you can think, are those qualitative measures? Are they ordinal or nominal? And the quantitative variables, are they discrete or continuous? Okay, glad you're starting to learn some of this terminology. And the next video, we're going to talk about different ways, again, that we can sample and collect sample data.